Alright, time for a little lesson about rational exponents. First thing you need to do is make sure you have the notes. It's got examples and everything. You can check the website there for this section. And then this one's going to apply a lot on the first section of your assignment. It's basically if you have some sort of rational exponent like x to the 7/3, the 7 is the power on x, and then this is the root. You can convert it into a radical. It's got a third root, and then it's x to the 7th inside there. You can also have it like this, where 7's on the outside. Either or, both are equivalent to the same thing. And so this first section is just you're converting it into the fractional exponent. So you're going to take 10b, and it was the square root, which is the 1/2 power. And then this guy here, the 4 is going to be on the bottom of our fraction, and 5's the top. So it's going to be 10x to the 5/4 power. On the this one here, this only happens, this 1 over, is if the power is negative, because that's equal to the third root of 5k to the 4th to the negative 4th power. And so to rewrite this, you put 5k, and the fractional exponent is going to be 4/3 and negative, and it gives you that guy there. The next section is going the other way. So remember, the top one is the exponent, and then the bottom, the denominator, is the root that you're going to do. So this is the 4th root of 10 to the n to the first power. But that doesn't do anything. This one here, remember, negative exponents means it's a fraction. So this is equal to 1 over 5n to the 7/4. And that 7/4 means you're going to have 5n to the 7th power. And the 4 means it's a 4th root. So we're going to get an expression looking like this. And we're going to go through a few of these ones so you can kind of see what's happening to the exponents. It's not really converting between the two forms, but it's just simplifying these rational exponents. If you have an exponent to another exponent, you times them together, so it's going to be x to the 7/4 times 7/4 power. And 7 times 7 is 49, and 4 times 4 is 16, so it's x to the 49/16 power. Next guy here, again, same thing. But it's got a negative in it, which isn't too bad. It's just a to the 2 times negative 3/2 power. 2 times negative 3 is negative 6. It's over 2. Well, that's just negative 3. Oh, and we don't want a negative exponent, so we're going to have to convert this into a fraction. So it's going to be 1 over a to the positive 3rd power, like that. And there's one more example. Towards the end, you have some harder ones. It's got fractions within fractional exponents and stuff like that. And so let's go through the process of simplifying this down so you can see a little bit harder one. Remember, if you have the same base in a division problem, you're going to subtract the exponents. So I'm going to just cross this out and subtract 3/4 like that power. And that's going to leave us with 3x to the negative 10/4 power. Okay, well, that's not too big of an issue. That just means it's a fraction, as when we put it on bottom. So it's going to be 3 over x to the 10/4. Oh, but we've run into a problem. We have a rational exponent or a fractional exponent in the denominator, and our instructions say not to do that. Well, it's not too hard to fix that. All you're going to do is take this right here, this fraction, and you're going to times by something that's equal to 1, that will make the top here positive. And let me show you how that works. We're going to times by x divided by x. And what that's going to do is these exponents here are going to be added, and then this one just needs to match this to make this entire fraction equal to 1. And so negative 10/4 is equal to negative 2.5. And so if I want to figure out what I need to add, what number this needs to be to make it this not negative anymore, I just need to add an integer that's going to turn this into a positive. Well, the integer that I'm thinking of is just 3. If you were to take negative 2.5 and add 3, then it would become positive. Well, you want the bottom to be 3, and you want the top to be 3, but adding these together, it'll be a little bit hard. So let's take this 3 and convert it into 12/4. Remember, 12/4 and 3 are the same number, and so all we're doing here is timesing by 1. So we're not changing the value of our expression here, because when you times by 1, you get the same thing. Well, it's going to leave us with 3 times x. Well, you got negative 10/4 plus 12/4, which is 2/4. And then on bottom here, we just got x to the 3rd power. And this is almost done. This can be reduced, and so you get 3 to the x to the 1/2 power. And on bottom, we got x to the 3rd. And that gives us that. So that's how you turn it into an expression that does not have a rational exponent in the denominator. Kind of a little bit roundabout way of getting there, but that's the main idea, is if you can't times by something that's equivalent to 1, so times by x over x, but they have the same power. And you'll get that. The end.